Here, you have to integrate x raised to 5 upon under root of 1 plus x cube. Your inner function is 1 plus x cube. You have to assume 1 plus x cube is equal to t. If we differentiate both the sides, we will get 0 plus 3x square dot dx is equal to dt. That means we need x square within the multiplication of dx. So let's split this x raised to 5 in terms of x cube into x square. That's x square dx objective. So we should move this 3 on the right side. So we will get x square dx is equal to dt by 3. So we are ready to modify our integration. The value of x cube is simply t minus 1. So let's replace our x cube by t minus 1 and x square dx will become your dt by 3 and in denominator under root of t. Now we don't have to worry about this 1 by 3. Let's give individual denominator. So in first term we will get t upon root t, or we can say t raised to 1 by 2 minus in second term we will get 1 upon root t, or we can say t raised to minus 1 by 2 dot dt. So we are ready for integration. Integration of t raised to 1 by 2 will be t raised to 3 by 2 upon 3 by 2 minus integration of t raised to 1 by 2 will be t raised to 1 by 2 upon 1 by 2 plus c. Now in further simplification we can take 2t raised to 1 by 2 common. So we will get t by 3 minus 1 plus c. If we take LCM, 3 will be multiplied over here and we will get 2 by 9 t raised to 1 by 2 t minus 3 plus c. Now to get the final answer, we just have to substitute the value of t. So will become 1 plus x cube raised to 1 by 2 and here we will get 1 plus x cube minus 3 plus c. This 1 and minus 3 can be rewritten as minus 2. So 2 by 9 under root of 1 plus x cube into x cube minus 2 plus c is your final answer, which is given in option D. Ta-da! In this question, you have to integrate x square plus 1 upon x into x square minus 1. Order of numerator is 2 and order of denominator is 3. So we can apply partial fraction, but before we go for partial fraction, let's get proper factors in denominator. Your x will be as it is, but this x square minus 1 can be split into x minus 1 and x plus 1 dot dx. So we are ready to apply the partial fraction. So let's begin from the first step, in which we have to assume proper terms. Now we have three factors and all factors are linear factor. So we can say for x you have to assume a by x plus for x minus 1 you have to assume e upon x minus 1 and finally you have to assume c upon x plus 1. Now to simplify right hand side, let's take an LCM of x, x minus 1 and x plus 1. So your a will multiply with x minus 1 and x plus 1. Your b will multiply with x and x plus 1 plus your c will multiply with x and x minus 1. Your left hand side will be as it is. In further simplification, we can cancel out x, x minus 1 and x plus 1 in denominator. So let's remove it. So here we complete our first step. Now let's try to take second step, in which we have to find the value of a, b and c by assuming proper value of x. To get the value of a, the common factor in the rest of the two terms is x. So we just have to take x is equal to 0. So on left hand side we will get 0 plus 1, or we can say 1 is equal to a into 0 minus 1 and 0 plus 1 will give us minus 1 and plus 1 plus b into this x will become 0, and similarly within the multiplication of c we will also get 0. So here we have to neglect the term of B and C. So we will get A is equal to minus 1. Similarly, to get the value of B, the common factor in the rest of the two terms is x minus 1. So we have to assume x is equal to 1. So on left hand side we will get 1 plus 1, or we can say 2, where A is within the multiplication of x minus 1, or we can say 1 minus 1 will give us 0, plus B is multiplied with 1 and 1 plus 1, or we can say 2, plus your C is multiplication with 1 minus 1, or we can say 0. So here we have to neglect the term of A and C, and we will get B is equal to 1. And finally, to get the value of C, the common factor is x plus 1. So we have to take x is equal to minus 1. So on left hand side, we will get minus 1 square, which will be 1 plus 1, or we can say 2, where A is within the multiplication of minus 1 plus 1, or we can say 0, and your B, or we can say again 0, and your C is multiplied with minus 1 and minus 2, or we can say 2. So here we'll get C is equal to 1. So we get the value of A, B and C. Now in third step, we just have to use our equation number 1. So let's get our equation number 1. Now before we go for integration, we have to substitute the value of A, B and C. Your A is minus 1, your B is 1, and the value of C is also 1. To get the integration, we just have to integrate both the sides with respect to x. So on left hand side, we will get our I, and on right hand side, integration of minus 1 by x will be minus log x plus log x minus 1 plus log x plus 1 plus c. Now, if we apply the properties of log, we will have log a plus b minus c. So we will get log a into b, or we can say x minus 1 into x plus 1 upon c, or we can say x plus c, which can be rewritten as log of x square minus 1 upon x plus c, which is given in option A. Ta-da! Here you have to integrate x cube plus 4x minus 3 upon x square plus 4 is equal to ax square plus b tan inverse x by 2 plus c. Then we have to find a plus b. To get the value of a and b, we have to integrate our left hand side. The order of numerator is 3 and order of denominator is 2. Here the order of numerator is greater than order of denominator. So we have to use long division to reduce order of denominator. So let's divide our x cube plus 4x minus 3 by x square plus 4. To get x cube, we have to multiply x. X multiplied with x square will give us x cube, plus x multiplied with 4 will give us 4x, minus minus will give us 0, and remaining term is minus 3. So here we'll get your answer, which is your x over here, plus your remaining term minus 3 upon your denominator, which is x square plus 4 dot dx. Now we are ready to integrate. Integration of x will be x square by 2 minus 3 will be as it is. Integration of 1 upon x square plus 4 will be 1 upon a tan inverse of x by a plus c. So here we get 1 by 2 of x square minus 3 by 2 of tan inverse of x by 2 plus c. If we compare with the given right hand side, we will get a is equal to 1 by 2 and b is equal to minus 3 by 2. So we can say your a plus b is simply summation of 1 by 2 and minus 3 by 2, which will give us minus 2 by 2, or we can say minus 1, which is your final answer given in option B. Ta-da! Here we have to integrate sin log x plus cos log x. In this question, your inner function is log x. So let's assume log x is equal to t. Now, if we differentiate both the sides, we will realize we don't have the differentiation of log x within the multiplication of dx. So in this situation, we have to make x subjective. So we will get x is equal to e raised to t. If we differentiate both the sides, we will get dx is equal to e raised to d dot dt. So we are ready to modify our integration. This sin log x will become your sin t plus cos log x will become your cos t. This dx will become e raised to t dot dt. Now here we have f a t plus f dash t within the multiplication of e raised to t. So to integrate this kind of a function, we just have to neglect f dash t. So we will get sin t into e raised to t plus c. To get the final answer, let's substitute the value of t. So we will get sin t, or we can say sin of log x, and e raised to t will become simply x plus c, which is given in option B. Ta-da! Here we have to integrate x cube plus 3x square plus 4x minus 3 and the whole function within the multiplication of e raised to x, which suggests that we have to use the formula of e raised to x fx plus f dash x. So let's try to get the required format. Your e raised to x will be as it is. Our first term is x cube. So we are going to need differentiation of x cube, or we can say 3x square, which we already have. Now in next two terms, or we can say our next term is 4x. So we need differentiation of 4x, which is plus 4, but we have minus 3. So let's add and remove minus 4. So here your first term will be remain as it is, and in second term, let's say this 4x plus 4 is 1 unit, so e raised to x into 4x plus 4, and this minus 3 minus 4 will become minus 7 into e raised to x dot dx. Now we are ready for integration. In first term, we have x cube as fx and f dash x, which is 3x square. So its integration is e raised to x cube plus in second term your 4x is fx and its differentiation is available within the summation. So e raised to x into fx, or we can say 4x, minus 7 will be as it is. Integration of e raised to x will be e raised to x plus c. For further simplification, we can take e raised to x common. So we will get x cube plus 4x minus 7 plus c, which is given in option C. Ta-da! Here you have to integrate e raised to x upon under root of x into 1 plus 2x. Now let's multiply this root x within the bracket. So root x ones are 1 upon root x, and this root x multiplied with 2x will give us 2 into root x. Now if we consider 2 root x as your fx, so we will need f dash x is equal to 2 as it is. Differentiation of root x is 1 by 2 root x. So this 2 will cancel out and we will get 1 upon root x, which we already have within the summation of fx, and whole term is within the multiplication of e raised to x. So to integrate this term, we just have to neglect f dash x. So we will get e raised to x fx, we can say 2 root x plus c as your final answer, which is given in option C. Ta-da! Here we have to integrate x raised to 4x, or we can say we have x raised to x raised to 4. We know that the differentiation of x raised to x simply x raised to x 1 plus log x. We need to set the differentiation of x raised to x. We have 1 plus log x, so just take 1 power of x raised to x within the multiplication of 1 plus log x. So here we'll get 3 power of x raised to x dot dx. So basically here we have fx whole raised to 3 into f dash x form, and its integration is simply fx whole raised to 4 by 4 plus c, or we can say x raised to x whole raised to 4 by 4 plus c, which can be rewritten as x raised to 4x upon 4 plus c, which is given in option A. Ta-da! In this question, we have to find under root of 2 integration of sin x upon sin x minus pi by 4. In denominator, we have x minus pi by 4. So, to simplify, let's assume x minus pi by 4 is equal to t. So, we will get x is equal to pi by 4 plus t. Or we can say your dx will become dt. So, we are ready to modify our integration. Your sin x will be converted into sin of pi by 4 plus t. And in denominator, this sin x minus pi by 4 will become your sin t dot dt. Now, to simplify our numerator, we have to apply the formula of sin alpha plus beta. So, its expansion will be sin alpha into cos beta plus sin beta into cos alpha whole divided by individual sin t. So, our function will be simplified as this sin pi by 4 is simply 1 upon root 2, and your cos t upon sin t will become cot t plus this cos pi by 4 is again 1 by root 2, and sin t upon sin t will cancel out and we will get 1 dot dt. So, if we multiply 1 upon root 2, we will get integration of cot t plus 1. Integration of cot t is log mod sin t plus integration of 1 will be t plus c. Now, to get the final answer, just substitute the value of c. So, we will get sin t, or we can say x minus pi by 4 plus your t is x minus pi by 4 plus c. We can consider this c minus pi by 4 as a new constant c dash. So, we will get log mod sin x minus pi by 4 plus x as your final answer, which is given in option D. Ta-da! Bye bye. Constant plus constant શું થાય?